Welcome to class, everyone. I am so incredibly excited to have you here for today's explainer. Go ahead and grab your notebooks because today we get to play the role of chemistry detectives. We're going to explore the fascinating world of chemical indicators and learn exactly how to decode the hidden secrets of the substances all around us. So, let's just jump right in.
Picture this. You're standing in the chemistry lab, and right in front of you is a beaker filled with a clear mystery liquid. How on earth do you figure out what it is? I mean, would you ever dare to just taste a mystery chemical to see if it's an acid or a base? No way! Absolutely not. That is a massive safety hazard. You know, a lot of incredibly dangerous acids look exactly like a plain old glass of water, but they can cause severe burns the absolute second they touch your skin. So the big question we're tackling today is, how do we identify unknown solutions safely without putting ourselves in danger? We need a special method.
Let me just circle our lesson plan for the day right here on the board. We're covering exactly what you need for your NCERT and CBSE curriculum. First, what are chemical indicators? Second, natural indicators around us. Third, olfactory indicators. That's the smell test. Fourth, lab-made synthetic indicators. And finally, our essential lab takeaways.
All right, Section 1, what are chemical indicators? The detective's safe tools. Okay, so here is the core definition you're going to want to jot down in your notes. Chemical indicators are substances that reveal acidic or basic nature through color changes. It sounds simple, right? But it is incredibly powerful. Honestly, think of an indicator like a spy's secret decoder ring. On its own, a mystery liquid just looks clear and, well, boring. But when you add that indicator, boom, it decodes the invisible properties of the liquid. An acidic solution is going to turn the indicator one specific color, while a basic solution turns that exact same indicator a totally different color. It's literally a secret code revealing what kind of chemical we're dealing with. And the best part, we don't have to touch or taste a single drop.
Moving on to Section 2, natural indicators around us, from nature to the kitchen.
You know, we really don't always need a high-tech, fancy laboratory to do chemistry. In fact, some of the absolute best indicators are obtained straight from plants and natural sources right in our own backyards. Let me tick off 4 main types for you here. First up is Litmus, which is actually a purple dye extracted from lichen plants. Second is turmeric. Yep, that bright yellow spice you probably have sitting in your pantry right now. Third, red cabbage, which gives us this amazing purple juice that changes color. And finally, flower petals, specifically from plants like the China rose or hydrangea leaves. Actually, quick fun fact, hydrangea flowers will literally change color in your garden depending on whether the soil they're planted in is naturally acidic or basic. It's such a great reminder that chemistry is happening all around us, in our kitchens and our gardens, not just the lab.
Now, the classic litmus test is an absolute staple in literally any chemistry class. Blue litmus turns red when it touches an acid, and I have a fantastic memory trick for your exams to help you keep this straight. Let's look at acids first. Acid turns red, and red stands for danger. Easy, right? And how do you remember the reaction for a base? Well, just remember the letter B. The B in base means the red litmus turns blue. Base equals blue. Keep those 2 little tricks in your back pocket, and I promise you'll never get them confused on a test.
Next up on our list is the turmeric indicator. Now, with acids, turmeric just remains yellow. There is absolutely no change at all. But drop it in a base, and it turns a deep, very distinct reddish brown. To help you visualize this, think about a super relatable real-world scenario. Have you ever spilled curry on a nice white shirt and gotten one of those stubborn yellow turmeric stains? Think about what happens when you try to wash it out. When you scrub it with soap, and remember soap is basic, that yellow stain suddenly turns this shocking reddish brown right before your eyes. That is a chemical indicator hard at work, right in your own laundry room. Pretty cool, right?
All right, let's see how this builds with our red cabbage magic. Red cabbage juice is exceptionally cool because it acts almost like a universal indicator. It gives us this beautiful spectrum of colors depending on the pH. Let's walk through it chronologically. Step 1. The original, neutral juice extracted from the cabbage is a lovely, deep purple. Step 2. When you introduce an acid, the juice shifts completely and turns a vivid reddish color. And Step 3. When you introduce a base instead, it turns greenish. It's just a fantastic step-by-step transformation. Because it gives us this super clear visual spectrum, it is hands down one of the most popular and fun experiments we get to do in school chemistry.
Let's shift gears to Section 3, Olfactory, the smell test, chemistry for the nose.
So, we've spent a lot of time looking at brilliant colors, but I want to remind the class that our detective work isn't just visual. The absolutely crucial point here is that olfactory indicators change their smell instead of their color.
They will alter or completely lose their natural odor based entirely on the pH level of the substance they're interacting with. This is incredibly useful, especially for visually impaired scientists, and it serves as another really powerful, highly reliable tool in our safe identification kit.
Take a close look at our 3 olfactory indicators here on the grid: onion, vanilla, and cloves. Let me just trace over this with my pen. Do you notice a distinct pattern happening? With acids, all 3 of these keep their characteristic smell. There is absolutely zero change to their natural odor. An onion in acid still smells sharply like an onion, but with bases, something entirely different happens. They completely lose their smell. The scent literally vanishes into thin air. So your simple, foolproof rule for the exams is this: acids keep the smell intact, but bases make the scent vanish entirely.
Okay, Section 4, Lab-Made, Synthetic Indicators, Formal Laboratory Tools.
Let's officially step out of the kitchen now and into the formal laboratory setting. Because unlike the cabbage juice or vanilla extract we just talked about, these indicators are completely man-made. They're synthetic chemical tools created and manufactured specifically in laboratory settings. Now, you might be wondering, why do we even use synthetic indicators if we already have these great natural ones? Well, in a professional or academic lab, we need extreme precision and consistency. A cabbage leaf might vary a bit depending on where it was grown, But a synthetic chemical, it's going to react exactly the same way, every single time. They just give us highly reliable, rigidly controlled tests.
Let me carefully highlight these crucial exam data points for you right here. We have 2 main synthetic indicators you absolutely need to memorize, and you're going to use these constantly in high school, especially during titration experiments where precision is everything. First up is phenolphthalein. In an acid, it remains totally colorless, looking just like water. But drop it into a base, and it undergoes this dramatic, instantly recognizable shift, turning a bright, vibrant pink. Second, we have methyl orange. This one turns red in an acid and shifts to a distinct yellow in a base. Definitely make sure you contrast these 2 clearly in your notes because they are an absolute favorite topic for examiners.
And that brings us to our final section, Section 5, Essential Lab Takeaways, Fingertips for the Exam.
Let's recap these core takeaways to make sure you have a rock-solid foundation for your next practical lab session and, of course, your written exams. Let me check these off on the board. First, remember that indicators show acid-base nature through either color or smell changes. Second, you absolutely must know the big 3 categories: natural indicators from plants, olfactory indicators that use smell, and synthetic indicators made in labs. Third, understand that these are absolutely essential for chemistry labs all around the world. And most importantly, they help us identify unknown solutions safely, without ever needing to risk tasting or touching highly dangerous chemicals.
And that brings us to the end of our lesson today. But wait, before you pack up your notes, I want to leave you with a quick challenge for your inner chemistry detective. I want you to look around your home tonight. Which natural indicator can you find hiding in your own kitchen right now? Think about the spices in your cabinet, maybe the flowers in the window, or even the vegetables sitting in the fridge. Science isn't just something that happens in a dusty textbook. It is literally everywhere around us. Thank you so much for joining this explainer. Study hard,